Now we're going to learn how to find terms in a geometric sequence. And geometric sequences are a little bit different than arithmetic sequences. Both are patterns that we can follow as we go from term to term. The difference is arithmetic, we were adding or subtracting a consistent value to change terms. Here with the geometric sequence, to go from term to term, we're either going to be multiplying or dividing by a value. So if we look at this first example, we want to find the sixth term of a geometric sequence that's defined by the numbers 8, 12, 18, and that pattern will continue on. The first thing we want to do with any geometric sequence, or any sequence for that matter, is find the pattern. So here, if I try to find it through subtraction, 12 minus 8 is not going to be the same thing as 18 minus 12, so I know it's not arithmetic. So what I'm going to check is if this is a geometric, which it is because it told us it was, but we can do that by figuring out the ratio, the common ratio. So R, or the ratio, is going to be the division of consecutive terms. So 8 dividing into 12, or I can say 18 divided by the 12. And either one of those is going to give me 1.5 or 3 halves. And I can write it either way, it's the exact same thing. So I can see that if I multiply 8 by 3 halves, I'm going to get 12. If I multiply 12 by 3 halves, I'm going to get 18, and that pattern is going to continue. Now, we could continue this pattern on and just continue to multiply by 3 halves a couple more times, because if I'm just going to the sixth term, I need 3 more terms. So if I continue that pattern, if I start out at the 18, 18 times 3 halves is going to give us 27. If I multiply that by another 3 halves, I get 40.5. And if I multiply that by 3 halves, I end up with 60.75. So my sixth term is 60.75. Now, we could do that because we were just going to the sixth term, but what if it asked for a much larger value, say the 20th or the 50th? I probably don't want to go term by term to get out to the 60.75. So another way we can do this is we can use our general form of an equals the first term, a1, multiplied by the ratio to the n minus 1 to help us out here. So if I want to get to the sixth term, I'm just going to plug in a 6. And our first term was 8, so 8 times the ratio of 3 halves raised to the 6 minus 1. And if I plug that into the calculator and make sure that this exponent gets grouped together, I'm also going to get 60.75. So I can do it either way. I can multiply out by multiple values of the ratio until I get to that sixth term, or I can just use our general form and say I start on my first term, I need 5 more of my ratio, and if I multiply that out, I end up getting the 60.75. Now we can look at the second one, which is very similar to that second way we did it, and we want to find the seventh term of the geometric sequence, defined by a sub n equals -2 times 5 raised to the n minus 1. Now, if it's already in that form where we have the equation, it makes it really easy. We can just plug in that 7 to get the seventh term. So a sub n, or a7 in this case, because we're actually trying to find the seventh term, so a7 is equal to -2 multiplied by 5 raised to the 7 minus 1. So that's really going to be -2 times 5 to the 6th. And if I multiply that out, the -2 times 5 raised to the 6th, I get a very large number, -31,250 is the seventh term in that sequence. Now, if I look at this, we didn't find the ratio because we already had the equation, but I can still see the ratio from the equation itself. Right here, this 5 is our ratio. So the reason this one got so much bigger is because we were multiplying by 5 every time instead of just multiplying by 1.5. So that 5 right there, or whatever that value is that's being raised to the exponent, becomes the ratio of the geometric sequence. So if we're trying to find terms in a sequence, we can either find the ratio and multiply by that ratio as many times as we need to get out to the desired term. Or if we have the equation, we can plug that desired term in and we can get straight to whatever term we're trying to find.